Hello, 8th graders. We're going to talk about balancing chemical equations and conservation of mass. So, subscripts we've already talked about. We know those show a ratio of atoms of elements in a compound. We know, for example, that CO2 has 1 carbon atom to every 2 oxygen atoms. So let's practice. If I have the chemical formula Fe2O3, how many iron atoms would I have? How many Fe atoms? 2. How many oxygen atoms would I have? 3. That little subscript, that little number underneath the letter, tells us how many atoms of each of those elements. Subscripts cannot be changed, so we're not going to mess with those numbers. All right, coefficients. This gives the numbers of molecules of a compound. So coefficients can be multiplied by the subscripts to give numbers of atoms of each element. For example, 3, see that big number 3? That's the coefficient. The little tiny 2, that's the subscript, like a submarine. So 3H2O means that there are 3 molecules of water, 3 molecules of H2O. So how many atoms of H are there total? Well, 6. 3, the coefficient, times 2, the subscript, gives us 6. 3 times 2 is 6. How many atoms of oxygen are there total? Well, I have 3 of those. So I have 3 O's. So 3 times 1, that understood 1 there underneath the 0, gives us 3. Now coefficients can be changed, and we're going to be changing these when we balance these equations. So balancing a chemical equation. A chemical equation uses symbols to represent a chemical change. So recall, we know the left side of this chemical equation. See, the chemical equation is made up of chemical formulas. The left side is what we call the reactant side. That's what you put together that reacts. That arrow means yield or make. So it yields or makes the right side, which is what we call the product. So when we put some amount of H2 plus some amount of O2, it will yield some amount of H2O. The subscripts we know are those little teeny tiny numbers. But the coefficients are what we need to figure out. How many of each one of these formulas do we have so that the left side and the right side are balanced or equal? So we're going to kind of step it out using some pictures here. So I have 2 black beads on a paper clip. That's representing H2. And I have 2 pink beads on a paper clip, and that's representing O2. And I have 2 blacks for hydrogen and 1 pink for oxygen on a paper clip. That's representing H2O. Now, is it currently balanced? Well, let's see. On the left side, I have 2 blacks. On the right side, I have 2 blacks. We're good so far. On the left side, I have 2 pinks. On the right side, I only have 1 pink. So we are not balanced. Now, it would be great if I could just stick another pink on this side and then we'd be balanced. But we can't do it that way. You can't just add 1 pink. You have to add what's in the paper clips. So, to balance that, I'm going to add 1 more paper clip of H2O. Now I have 2 pinks. I have 2 pinks on this side and I have 2 pinks on that side. So now my pinks are good. But did I mess up my blacks? Yes, I did. I got 4 blacks on this side and only 2 blacks over there. But what could I add so the left side and the right side were the same? I could add 1 more paper clip of 2 black beads. So now I have 4 black beads on the left, 4 black beads on the right, 2 pink on the left, 2 pink on the right. So the last thing I need to do now is to write in the number of coefficients. How many H2s did I have? I have 1, 2. So I have 2 H2s. How many O2s did I use? Just 1. How many H2Os did I use? 1, 2. So I have 2. So you have just balanced your first chemical equation. Yay! All right. So we're going to do some more examples in a minute on that one. But let's talk about the law of conservation of mass. So it states that matter cannot be created nor destroyed. So just like we balanced that last equation, we didn't destroy any particles, we didn't create any particles, we just balanced the left side with the right side. So the fact that we have the same number and the same kind of beads on the left side as we do on the right side means the mass on the left side is going to always equal the mass on the right side. So both masses will be equal. So in this case, if the left side, the 2 HGOs, weighed 10 grams, then the right side also should weigh 10 grams. So if I know the 2Hg is 9.3 grams, then can I figure out how much the oxygen would weigh? Well, I can take the 9.3 and subtract it from 10 to see what's left over, and I should get, whoops, where'd it go? Sorry, went crazy. Anyway, you should have gotten 0.7, so the left side and the right side are the same. All right, same thing here. Matter cannot be created or destroyed. I know that the number and the kind of atoms are the same on both sides of the reaction. This makes the equation balanced. 2 greens on the left, 2 greens on the right. 2 oranges on the left, 2 oranges on the right. That makes it a balanced equation. Likewise, it also would weigh the same. If the left side has the same atoms as the right side has, then they would both weigh the same. So in conservation of mass, no atoms are lost during a reaction. So if you start with 13 grams of iron and 0.5 grams of oxygen and end up with 13.5 grams of Fe2O3, the left side would be equal to the right side. Did y'all hear my dogs in the background? They're playing. Anyway, the mass of the reactant must equal the mass of the product. So we balance chemical equations so that there are the same number of atoms on each side of an equation. Not only the same number of atoms, but the same kind on each side. All right, we're going to work some more on that in the next video. Bye.